Hello everyone, welcome back to my channel. This is the part 4 of metals and nonmetals. In this video, we will learn about nonmetals. So let us see what are the contents of this video. Introduction of nonmetals, electronegativity, how do ionic compounds are formed, how do magnesium chloride, magnesium fluoride and calcium sulphides are formed, what are the properties, and at last we will going to solve some questions. So let us start. What are nonmetals? How do we define nonmetals? We can define nonmetals by checking the characteristic property. Nonmetals may be solid or gases, except bromine, which is liquid at room temperature. So, this is the first property of nonmetal, that they are usually solid or gaseous. But bromine, as an exception, it is liquid at room temperature. Nonmetals do not have luster, but iodine is a nonmetal which have a luster. Non-metal usually they are soft in nature, but diamond is hard. It is an allotrope of carbon. Carbon is a non-metal. Non-metal do not conduct electricity. Also, they are poor conductors of heat. But graphite is a non-metal which can conduct electricity. Let us see how. Non-metals are electronegative in nature. Now, what is this electronegative nature? So, we will going to learn about all these properties in this video. So let us first learn about why graphite conduct electricity or how graphite can conduct electricity. If we look about the structure of graphite, graphite is an allotrope of carbon and we know that carbon is tetravalent in nature. That is, it has 4 valence electrons. In graphite, out of 4 electrons of carbon, 3 are involved in covalent bonding, so they are packed. But one electron is delocalized and thus this electron moves whenever connected to a battery. That is, this one valency of carbon is delocalized between the rings of the graphite and this electron is mobile in nature. Thus, it helps in the conduction of electricity. But if we talk about the another allotrope of carbon, that is diamond, it do not have any free or mobile electron. Except graphite, no other non-metal can conduct electricity. All non-metals except graphite are poor conductors of electricity. Now let us talk about electronegativity. Why non-metals are electronegative in nature? Non-metals are electronegative in nature, this we know. Now what is this electronegativity? Tendency of atom of an element to gain electron and form negatively charged ion is known as electronegativity. That is, if atom gains an electron, then it forms a negatively charged ion. This tendency of gaining electron by non-metal atom is known as electronegativity. A more electronegative non-metal will show more non-metallic character. Electronegativity increases across the period and decreases down the group. What does it mean? It means that in periodic table, if we move from left to right, then electronegative character of non-metal increases. That is, the tendency to gain electron increases as we move from left to right in a period. But if we move down in a group, then the tendency of gaining the electron gradually decreases. So electronegativity increases across the period whereas it decreases down the group. All non-metal have this tendency of electronegativity. That is, they have a tendency to gain electrons and form negatively charged ions. Now let us talk about metals and non-metals reaction. How do metal react with non-metals or vice versa? Let us take an example of the formation of NaCl. Here in the formation of NaCl, you know that Na is a metal and chlorine is a non-metal. So why non-metal and metal react? Why do they react so easily? This is because both have opposite nature. Metals are electropositive in nature, whereas non-metals are electronegative in nature. Metal gives its electron, whereas non-metal gains electron. So metal by giving its electron forms a positively charged ion. Here in this, sodium has given its valence electron which is present in the outermost shell. Sodium has given its valence electron to the chlorine atom, and chlorine has gained one electron from sodium, and thus chlorine is converted into chloride ion. So by giving electron, sodium become positively charged ion. By gaining electron, chlorine has become negatively charged chloride ion. So this giving and gaining of electron results in the formation of ionic bond. Ionic bond is a bond which is formed between the two ions. This is an electrostatic force of attraction between the two ions. So, why metals and non-metals react? The reason is that metals are electropositive, non-metals are electronegative. So, both have opposite nature, hence they both react with each other and forms ionic bond. Now, what are ionic compounds? As we have seen that ionic bond is formed between metals and non-metals. This ionic bond results in the formation of ionic compounds. So, let us see. What are ionic compounds? Ionic compound is a chemical compound in which ions are held together in a lattice structure by ionic bonds. Now, what is lattice structure? Lattice structure is basically a structure of cube, just like a cube. It is compact. This ionic bond is formed between the ions. So, what are ions? Ions are basically formed by gaining and losing of electrons. Electrostatic force between oppositely charged bodies occurs, and this charged bodies are known as ions. This is the electronic configuration of some metals and nonmetals. We need to learn this configuration to make the bond or to see how the bonds are formed between the metals and nonmetals. Here are some common metals and nonmetals: sodium, magnesium, aluminium, potassium, calcium. And nonmetals we have nitrogen, oxygen, fluorine, phosphorus, sulfur, and chlorine. So let us see the magnesium. For example, if we need to form a bond between magnesium and chlorine, then we need to check the valency of magnesium and chlorine. Magnesium being a metal, just look about the valency of magnesium. It has two valence electron in the outermost shell. Now, if we talk about chlorine, then chlorine has 7 valence electron in its valence shell. So, magnesium will have a tendency to donate this electron because magnesium is a metal, and it will easily donate this 2 electron and will have an outermost configuration of 8. Similarly, chlorine will also attain the outermost configuration of 8 by gaining this electron from the magnesium. So let us see how magnesium chloride is formed. Let us practice the formation of magnesium chloride, magnesium fluoride, and calcium sulphide. Metals are electropositive and have a tendency to lose electron and form positive ion. So metal in an ionic compound will lose electron. Non-metals are electronegative and have a tendency to gain electron. So in ionic compound, non-metal will gain the electron. These positive and negative charges thus attain the electronic configuration of nearest noble gas. That is, they will tend to make their outermost orbit as a octet, and finally held by strong force of attraction, and salts are formed. Let us see how. Formation of magnesium chloride. Here magnesium chloride is an ionic compound where magnesium is a metal and chlorine is a non-metal. So let us see the outermost configuration of magnesium in the figure. In the outermost configuration, you can see that magnesium has 2 valence electron in the outermost shell. If we take a look on the outermost configuration of chlorine, you can see that in the outermost shell of chlorine there are 7 valence electron. So chlorine needs to gain 1 electron to complete it octet, whereas magnesium needs to give its electron to complete its octet. So in both the cases, chlorine as well as magnesium both will attain nearest noble gas configuration, and thus both become stable. So what will happen? Magnesium will give its electron to the chlorine, and chlorine will gain the electron from the magnesium. Since magnesium has given its two of its electron, so magnesium will gain 2 positive charge. Since chlorine has accepted 1 electron from magnesium, so chlorine will acquire 1 negative charge. So ions are formed and strong intermolecular forces of attraction occurs between these ions, and this results in the formation of ionic bond. So this is the formation of magnesium chloride. Similarly, magnesium fluoride will also form. Here, magnesium is again a metal. It will donate its electron to fluorine atoms, whereas fluorine will gain one electron from the magnesium. So, magnesium, by giving its electron, will form Mg2 plus ion, whereas fluorine, by accepting electron, will form F minus ion. So, two fluoride ions will connect with one magnesium ion in the magnesium fluoride. So, this is how the magnesium fluoride is formed. Now let us see the formation of calcium sulphide. Here the calcium is the metal, so calcium will donate its electron, whereas sulfur is a non-metal, so sulfur being electronegative will accept the electron. Let us first look the electronic configuration of the calcium. Here electronic configuration of calcium is given 2882. So calcium has two valence electron in its outermost shell. So it will lose these electron and will attain the nearest noble gas configuration of 8. Also sulfur, let us see the configuration of sulfur. It has 286 electrons. So sulfur has 6 electron in its outermost shell. So sulfur needs 2 electron to complete its octet. So sulfur will gain 2 electrons and will form sulphide 2 negative ion, whereas calcium will donate 2 electron and will form calcium 2 plus positively charged ion. So these two ions will combine to form ionic bond, and this will result in the formation of an ionic compound, calcium sulphide. So in this way, we can form the ionic compounds. We just need to check which one is metal and which one is non-metal. And then in the second step, we need to check the electronic configuration. After checking the electronic configuration, we need to check the valence electron of both the atoms. And we know that metals are electropositive, so metal will lose its valence electron, and non-metal being electronegative will gain the electrons donated by the metals. And thus positively charged ion and negatively charged ions are formed. And this will result in the formation of ionic compound. Now what are the properties of ionic compound? Ionic compounds have high melting and high boiling point because these bonds are strong. Ionic compounds are hard but brittle. They are mostly crystalline solid at room temperature. They have proper crystal lattice and they can conduct electricity when in molten state. So when we take ionic compound in a molten state, then ions are released and these ions are mobile in nature. So they move towards the oppositely charged electrode and thus helps in the conduction of electricity. So ionic compound in a molten state can conduct electricity. So let us learn the summary of this video. All metals except mercury exist as solid at room temperature. Gallium and cesium have very low melting points. These two metals will melt if you keep them on your palm. Iodine is a non-metal but it is lustrous. Carbon is a non-metal but can exist in different forms. Each form is called an allotrope. Diamond, an allotrope of carbon, is the hardest natural substance known and has a very high melting and boiling point. Graphite, another allotrope of carbon, is a conductor of electricity. Alkali metals, lithium, sodium, potassium, are so soft that they can be cut with a knife. Now, what are the learnings from the video? Let us solve these questions. Why metal react with a non-metal? The answer to this question is metals are electropositive, non-metals are electronegative. Both have opposite nature. So metal have a tendency to donate electron, whereas non-metal have a tendency to gain electron. So both, by gaining and losing, they form ions. And these ions are attached with each other by the strong intermolecular forces. And thus they form ionic compounds. Now second question, name the non-metal which is hard. Diamond is a non-metal which is very hard. Name the non-metal which is lustrous. So iodine is a non-metal which is lustrous in nature. Next question, why graphite conduct electricity after being a non-metal? Yes, we know that non-metals are insulator. They do not conduct electricity. But graphite as an exception can conduct electricity. This is because in graphite, carbon is tetravalent, but 3 of its valencies are satisfied by the carbon and 1 of its valency is delocalized between the rings, and this valency helps in the conduction of electricity. Next question, What are ionic compounds? Ionic compounds are the compounds which are formed between the ions. How ions are formed? A cation is formed by losing the electron by metal, whereas anion is formed by gaining the electron by non-metal. So these ions, they are attracted by the strong intermolecular forces, and thus they form ionic compounds. For example, magnesium fluoride, magnesium chloride, calcium sulphide, etc. Now discuss the formation of NaCl. NaCl is a salt which is formed by the ions of sodium and chlorine. Sodium, being a metal, releases its electron and forms sodium ion. Chlorine, being a non-metal, gains the electron and form a chloride ion. Thus, the ions which are so formed by gaining and losing of electron, they are attracted and attached by strong forces of attraction, and this is known as ionic bond. And the compound which is formed by this bond is known as ionic compound. So NaCl is an ionic compound which is formed by sodium metal and chlorine non-metal. We have already seen the formation of NaCl in this video. So I think by this video we have got an understanding about the ionic compounds and their properties and their formation. Thank you.